All right, in this video, I'm going to be talking about the quadrantal angles. Those are the ones on the axes. So 90, 180, 270, and then 0 or 360, either one. So I talked about these in the unit circle video, but just to recap, this is the unit circle, right? So these are, 0, 1, -1, 0, and so on, with x corresponds to the cosine of theta and y corresponds to the sine of theta. So this is a really good way to help you remember your the sines and cosines of your quadrantal angles, just by picturing the unit circle in your head. Hopefully, that's the goal anyway. So as an example here, we have this 90-degree angle, and I can see right away that x is 0, so cosine of 90 is 0, and sine of 90 is 1, right? Okay, so let's move on. So here, we're asked for the sine and cosines of different quadrantal angles, and we are going to use our unit circle to find those. So negative 90, right, we're going this direction. So negative 90 is here. So the cosine is x, so cosine of negative 90 is 0. And sine is y, so the sine of negative 90 is -1. 360 is the same as 0 on the unit circle, so that's going to be here. So the cosine of 360 is going to be 1, and the sine of 360 is going to be 0. 540 is bigger than 360. So to get this down to a number that we recognize, I would subtract 360. So remember in the last video, we talked about coterminal angles. We said that if I add or subtract 360, I'm not changing the angle. So if I have a number that's bigger than 360, I would want to subtract 360 so that I get it down to a number that I'm used to seeing, because I'm not used to dealing with angles bigger than 360. So we're going to do 540 minus 360, which is 180. So this is really a 180-degree angle. So that puts us over here, right? 180 degrees. So this is 180 degrees. It's also 540 degrees. Okay, so now that we know that, we know that the cosine of 540 is going to be -1. And the sine of 540 is going to be 0. So once you know where you are in your unit circle, it's really easy to find the sine and cosine of your quadrantal angles. All right, let's do another example. Sorry, I forgot what I was doing for a second. Okay, so let's talk about finding exact values that, aren't quadrantal angles. So if I have sine of 45 degrees, hopefully I'm loading in my head either my 45, 45, 90 triangle or my my unit circle. I should be loading one of those two things in my head. So here's my 45-degree angle. My 45, 45, 90 triangle looks like this. So I can say, okay, the sine of 45 is 1 over the square root of 2. which we talked about in the unit circle. If I rationalize that denominator, that's going to be the square root of 2 over 2. That's how we always write it, square root of 2 over 2. And then cosine 45 is going to be also 1 over the square root of 2, which is again square root of 2 over 2. I can also know that this point, so if I have the unit circle in my head, I know that this point looks like that, and so this is cosine and this is sine. And I can find it that way. So you can either use the triangle or you can use this. Remember that we used the triangle to find this originally. So they are really giving us exactly the same thing. It's just whichever one is stuck in your head, whether it's the unit circle or the triangles. I think for most people it's the triangles because they're just easier to remember than picturing an entire unit circle in your head. But being able to find this quickly will definitely help. And if you're struggling with that, maybe have another look at the tips video that I put up, tips on finding or remembering the unit circle. Okay, let's continue. So these are our answers over here. Let's go to the next one. So now what if it's 60 instead of 45? So in that case, I have a 30, 60, 90 triangle. Instead of a 45, 45, 90 triangle. So this was my 45-degree angle. Here's my 60-degree angle. So, that is the worst triangle. So this is 1, 2, square root of 3. Or I can remember from my unit circle that this is going to be sorry, that's square root of 3 over 2. It's kind of hard to see. So if I know my unit circle and I know this, or I can find it using my 30, 60, 90 triangle. So either way, sine is this one, square root of 3 over 2, or opposite over hypotenuse, square root of 3 over 2. And cosine is adjacent over hypotenuse, or 1/2. Also this one, right? Okay, so that would be my 60-degree angles. All right, now what if I'm asked for 245? 245 is not in the first quadrant. It's not in the first quadrant, so I need to figure out what my reference angle is here. I know that this is in the third quadrant. It's over here. So 180 plus theta, where theta is my reference angle, is 245. So theta is going to be 245 minus 180. Which is 65. 65 is not a special angle. It's not a special angle. So this says find exact values. We don't actually have a way to do that because this is not a special angle. So sometimes, so right now, in pre-calc, we'll have ways to find more exact values. Still not all of them, but more than we have now. But for now, the only exact values that we can find are for quadrantal angles and angles that have reference angles of 30, 45, or 60. Those are the only ones. So we can't actually find exact values for this one. We can find approximations, right? We can do, we can put it in the calculator and get an approximation. So if I put sine of 245 in a calculator, I'm going to get negative 0.906. Why is it negative? Well, remember, tangent is the only thing that's positive in the third quadrant. So sine has to be negative. Remember, all students take calculus. So this is going to be negative 0.906. But this is not an exact value. This was asking for an exact value, but I couldn't give it an exact value. I didn't have that. So I'm giving an approximation even though that's not what they're asking for. You might put no exact value. There might be a way of finding it, but we haven't learned it yet. So at this point, you would state that you can't find an exact value, and then you would give an approximation. This, by the way, is over here somewhere. And then for cosine, again, the cosine is also going to be negative because, again, tangent is the only thing that's positive in this quadrant. 0.423. So your calculator tells you that this is negative, but if you are in fact finding an exact value, it's not going to tell you. You're going to do your little triangle, and then you're not going to know if it's positive or negative. So you'll have to use these rules to tell you, okay, this must be negative. So bear that in mind, and let's go on to the next question. This is shifted from the others, so I'm just going to erase it. All right, so for this one, we're finding negative 45 degrees. We've already found positive 45 degrees. We know what that was, but this time we're finding negative 45 degrees. So negative 45 degrees, we're going to come down, right? So negative 45 degrees is this one. It's still a 45, 45, 90 triangle. So you still get square root of 2 over 2. This is still 45, so it's still 45, 45, 90. So just like we got in the first example, we would have the same thing here, but in this case, something is negative. What's negative? Well, y, right? Y is negative. So this is going to be negative. Also, that's sine, right? So sine is going to be negative. So we could look here and say, okay, well, cosine is positive in this quadrant. So cosine is positive, sine must be negative. So you can either look at it by looking at this, or you can looking at over here and say, well, in this quadrant, x is positive and y is negative. So x is positive, y is negative. So either way you think about it, you can end up with the right signs. So sine is going to be, side note, it doesn't actually make any sense if you don't have an angle written here. So that was me being sloppy. Sorry about that. But sine and cosine don't actually make any sense if they don't have an angle associated with them. So this is going to be negative square root of 2 over 2. And this is going to be positive square root of 2 over 2. So that's for negative 45 degrees. Okay. Also, we could have added 360 to figure out what our reference angle is, but if you're negative in this quadrant, it's pretty obvious what your reference angle is. It's just the positive version of this. So we didn't need to do that. Okay. So let's do one more of these. Last one of these. Okay. So in this one, nope, we've already done those. Never mind. We're not doing one more of these because this is exactly the same as one we've already done. So hopefully that all makes sense with finding exact values. Again, if it's not a special angle, you can't find the exact value. And I just dropped my calculator. Whoops. And then obviously if it's negative, you go in the other direction. And then using these rules to figure out if sine or cosine is supposed to be positive or negative. You can also use what you know about graphs to figure that out. Either way you think about it is fine as long as you get the correct answer. So that's finding exact values. Hopefully that helps, and I will see you guys in the next video.